Okay. Previously we have seen algebraic expressions. So algebraic expressions means what? Starts with the definition of a constant and a variable, the value which cannot be changed, cannot change itself across the time. It's called as constant. Where it can take numerous values is called as variable, right? Likewise, using the constant and variable, a combination product of one or two constants or more variables, we call it a term. If the variables involved in the term has the whole number as their power, non-negative integral power, if it has means we call that term as a monomial. An expression which contains one or more than one monomials is called as a polynomials, like we have seen. Okay, so it's a polynomial expression. What is it? Some ax square bx plus c. Likewise, if you are writing means it is a polynomial expression. In that, if we restrict the leading coefficient getting 0, this a should not be 0, as well as we name the polynomial as p of x. The polynomial expression named as a p of x, because p is the first letter of the word polynomial. We can use any alphabets, r of x, q of x, whatever it is called polynomial. It is not necessarily of the power 2. Okay. So before getting understanding the polynomials, first we should understand monomials. The degree of a monomial. What are all monomials? We say 2xy is monomial, 5x square y is another monomial, 7xy is the monomial. Likewise, single term that may contain one or more than one variables. Okay. Now the degree of a monomial, how it is calculated? You know, the sum of, do you know? Sum of the powers of all the coefficients. So degree of this, here power 1, here power 1, 1 plus 1, that is 2, and this here power 2, there power 1, 3. Here 3 variables, each has power 1, so we call the degree as 3. This is the degree of a monomial. When it comes to degree of polynomial, I hope we have covered the general form of a polynomial there itself. What is the difference between that and this one is, from a polynomial expression to directly polynomial, how we'll see means because of this only will be the slight difference between that and this. We name it and we restrict the leading coefficient to become 0. That is the difference. Okay. Unless in an algebraic expression, it can be anything. But particularly this is a polynomial, if you want to say means leading coefficient should not be equal to 0 and then we name it. That is the difference. And the general form, what is the general form? a0, a1x, a2x square and so on. In this, the leading coefficients an should not be equal to 0. Okay, that is the general form of a polynomial. Now in this, the degree of a polynomial, simply you may say that it is a leading degree, which is the highest number, but actual definition is polynomial consists of one or more than one monomials. So 2xy y square, here let me take z square, x square z square plus y square plus 2xy plus 2yz plus 3xyz. We may take this as a polynomial. Each one term is a monomial. You see. Now what is the degree of this polynomial? Is the highest degree of monomials which is contained in the polynomial. This has how many monomials? 1, 2, each term is a monomial, right? So 1, 2, 3, 4, 5, 6 terms it has. We find out the degree of each monomial. Let me write in this way. The degree of this term is what? 2. Don't consider this x by 2. The degree is 2 I am writing. Okay. Okay. Now this one degree is 2 again. This is 2 again. Now here two variables have the sum of the degrees, sum of the powers of the variable. So 1 degree is 2 again. Here degree is 2 again. Here degree is 3. Because 3 variables, each power is 1. 1 plus 1 plus 1, that is 3. Now, which degree is the highest among this? Which one is the highest among this? 3. Yes, that 3 alone we can call it as a degree of this whole polynomial. Now here we have a0, a1, a2, x power 2 and so on it goes, x power n up it goes. What is degree of this polynomial? What is degree of this polynomial, do you think? N. That is it. Okay. After this, we have a definition called value of the polynomial. So far, whatever the examples I gave, it consists of more than one variable, right? So it is a monomial of monomial in 2 variables. This is a polynomial in 3 variables because 3 different variables are involved, and that is a polynomial in 1 variable, and it is the general form of polynomial in 1 variable. Usually we will work out in this section. Considering this section, we will be seeing only the polynomial in 1 variable. Okay. So only this is the general form we are going to see. Now, the value of a polynomial. Let me take some examples. Some r of x, why always p of x? We'll take something. 2x square plus 3x plus 1. Like I am taking one polynomial for an example. Now, value of this polynomial at a given particular point at x is equal to 1, which means we have to substitute the value x into this polynomial. Wherever x is there, we have to substitute. As I said earlier, where we will substitute? Whenever the player is not there. In which place that player is not there, in that place we will substitute. Here 2 places. Both the places x has to be substituted as 1, and that is mentioned as r of 1. This I didn't told you before, I think. Yes, everywhere, wherever x is there, that place we have to substitute. Now 2 into 1 square, 3 into 1 plus 2. So that is 2 plus 3 plus 1. 1 square is always 1. So we have 6 as the answer. That is the value of this polynomial r of x at 1. It is called as r of 1. Okay. Next, the coefficient, leading coefficient, 0 polynomial, 0 degree polynomial. Do you know anything? You read about those. No, man. You see, 0 polynomial is different, 0 of a polynomial is different. So far we have seen up to degree, right? So based on degree, we define 0 polynomial, also constant polynomial. Okay. So 0 polynomial means in a polynomial all the coefficients are 0. All the coefficients are 0. What are all the coefficients? a0, a1, a2, like all the coefficients. So from a0, a1, a2 and so on up to an. Every coefficient becomes 0. Then this polynomial is called as 0 polynomial. Which clown is making fun over there? Call that boy inside. Come inside, we'll learn polynomials. So all the coefficients are 0. Came or not? Came or not? Not same. He asked came or not. Better be quiet or else get inside. Now come back here. It's a 0 polynomial, which is in which all the coefficients are 0. Okay. And the constant polynomial. Constant polynomial means it's a constant. There will be no variable in it. Okay. So p of x equals 7. Like I am writing it. Is there any variables? No. It's a constant polynomial. But yes, there is a variable that is playing hide and seek. That we have to figure it out. We have to find out. Whatever variable you put, the power will be 0. Because we have the exponent and power concept. X power 0 is 1. Anything power 0 is 1. So that is it. Okay. Now what is degree of this constant polynomial? Degree of this constant polynomial is what? 0. Okay. So if a degree of the polynomial is 0, we call it as a 0 polynomial. Is this only x variable can be written? This is a polynomial in how many variables? Infinite variables. You can write if possible. But as per the definition, the constant polynomial which has no variable in it. Okay. Variable should not be present. If present also, that should be in the power 0. Okay. Now come back here. If all the coefficients are 0, what would be our polynomial will be like? 0x square, 0x plus 0 like we will write. Okay. Now what is degree of this 0 polynomial? No man, see leading coefficient. X square is the highest power. Okay. Then you are saying 0 as degree of this, which means that here something power 0, it is 1 only, right? There is no 1. You say 0 power 1. Okay. Then 1 will be the degree, right? Degree means what? Highest power. Okay. What is the variable you are writing? X power 1 na? Okay. X power 0. You are saying 0 is the degree of the polynomial, of this 0 polynomial. I am giving you another example. As per this, you may say 2 because it is a leading coefficient. Like 0 power 0 into x power 100, 0 into x power 99. Likewise, you may write no. No, it won't be 0 because when you say this kind of an example, I'll give you one example like this as 2. When we fix 2 as the degree of this polynomial, I'll say come up with another example like this. In this case, the degree is 0, leading coefficient. So the thing is, degree of a 0 polynomial cannot be determined. It is not defined. Degree of 0 polynomial is what? Important point. not defined or cannot be determined. You may say, okay. This is about polynomials, zero polynomial, zero degree polynomial. Can you distinguish the difference between zero polynomial and a zero degree polynomial? What is zero polynomial? What is zero degree polynomial? Factor. See, man, I asked you the difference between zero polynomial, that you said clearly. Then zero degree polynomial I am asking. Polynomial having degree as 0 is called as what? Okay, don't get yourself confused. You have to know the difference. Okay, that is it about degree of a polynomial. Next, you have seen the value of the polynomial, right? Now, the zero of polynomial. Take the polynomial p of x is equal to x plus 1 simply. The value of the polynomial at x is equal to 1. It is what? P of 1. It is 2. Value of polynomial at x is equal to 2. Then it is 3. Value of polynomial at x is equal to 4. It is 5. What is the value of the polynomial at minus 1? 0. Now, when you substituting a value, the value of the polynomial is 0. The value of the polynomial is 0. Then the substituted value, the substituted number is called as 0 of a polynomial. Minus 1 is the 0 of the polynomial. That is it. How many zeros like this may exist? It depends upon the degree. How many such 0 will exist? Degree. If the degree is 1, we may say at most 1 0. Degree is 1 means at most 1 0. Degree is 2 means at most 2 zeros. So, whatever the degree, at most the number of degrees, that many zeros may exist for a given polynomial. Okay, and everything else is simple. You know about the division algorithm, right? The polynomial p of x, when it is divided by some g of x, let me say, then there exists q of x and r of x such that p of x is equal to g of x into q of x plus r of x. Whereas this r of x is what? Remainder. And this q of x is quotient. This is divisor. This one is dividend. Okay. This is called as division algorithm. Now in this, without even dividing it, without finding the quotient, how can we substitute, how can we find the remainder? When p of x is divided by, let me write on this way, g of x is x minus a, g of x is in this form, x minus a form, then the remainder is p of a. That is it. Then the remainder is p of a. Likewise, this is what is called as a remainder theorem. What theorem? We previously talked about this earlier, right? Likewise, if when you substituting this r of x, this r of x value becomes 0. r of x is equal to 0 when g of x, the divisor is x minus a, then we may say x minus a is a factor of p of x. Okay, this is the one scenario. If p of a is 0, then x minus a is a factor. The other way, if x minus a is a factor, then p of a is equal to 0. This phenomenon is called as factor theorem. Okay, can you relate one with another? No. There are some examples as well, and there is an exercise. See that exercise whether you can do or not, tell me. Yes, find the roots of the polynomials. Which of the following is, oh, that will solve, man. Okay, how to find the 0 of a polynomial? Usually in the scenario of polynomials, we call that number as 0. When it is an equation only, we will call it as a root. Okay, see, whenever we need to find the zeros of a polynomial, for example 4x square minus 1, we need to find the 0 of a polynomial. For what value the polynomial will get 0? So for that, first let us name this. I am telling you in the point of view of descriptive manner. Okay, but objective manner directly you can do. And we say that 4x square minus 1 equal to 0. Equate that to 0 and equate everything to x. That is it. So when we have 4x square, this minus 1 transposed to the other side, we have plus 1, and x square is equals 1 by 4. Then x equals plus or minus 1 by 2. That is it. See, I told you, when degree is 2, you can have at most 2 zeros. So plus 1 by 2 is 1 0. For minus 1 by 2 also it will become 0. So there are 2 zeros. At most means there can be no zeros possible also is there. When no 0 is possible, that means that there is no real zeros are there. Those are the different things, but so far there is a possibility that there can be no zeros. 1 0 also possible, but maximum it will go 2, not beyond that. That is it. And then you see the exercise third subdivision. Which of the following are polynomials? Can you say? Is that only option B?